Thank you very much for joining. We all know. Oh, thank you. Thank you. We all know Flutter Web is not really the favorite child in the Flutter family. This is exactly why I wanted to do this talk, because maybe I'm not going to change that, but I will try. So you all know the situations, right? Like when you set your mind on something, you have this goal and you think like, this will be awesome. This is my goal and I'm going to sit down for a weekend. I will work on it. You're in the flow and you just solve the problem. And for this talk, actually, I want to tell you a story which is completely different because it started like this, it went to this, and it ended up like this. And the reason for that was because this topic is not only, like, there's not many resources about it, and it's not like just a topic that Flutter people gave up on, but it's a topic that should not be possible, and my goal was to kind of still make it possible somehow. And I had a lot of fun with it, and I had a lot of nerves, or I needed a lot of nerves, and so I will use this talk as a therapy session to talk about my feelings and to tell you all about it. So without further ado, my name is Simon Auer. I'm the CEO of Markably, an agency in Vienna. I'm the co-organizer of the Flutter Vienna meetup, and I'm on LinkedIn and X. So let's quickly talk about the agenda, because I don't just want to share my feelings. I also want you guys to have a little bit about it. So I'm going to start with some Flutter or web basics for people who are more in the app space, just to get everybody on board. Next up, I'm going to talk about some fixes and optimizations that you can use in every Flutter Web project that will definitely help in some way. And last but not least, we'll come to my favorite part, like the crazy stuff that really should not exist. And I will just show you through some of the weird things that go on in my brain. So yeah, let's talk why we should use Flutter Web. And this is how I try to convince people. So of course, like if you want to create a web app with a nice type-safe language, Flutter is a really good choice, of course. If you have users that need or prefer a web version, you might have an app already, but you want to be able to extend this with a web version. It's super cool. Flutter, just one command, Flutter build web, and you already have a web version of it in most cases. The other thing is if you want to offer a trial, and I think this is something that's often overlooked. I hear a lot of Flutter developers who develop their indie apps and say, OK, I don't need a web version. I just want people to download my app. But in reality, a lot of people actually don't want to download every single app just to test it out. In some cases, it could make sense to make a minimal version of your app, provided with a low barrier on a website for people to try out. And if they like it, you could upsell them to actually download the app. And because you use Flutter, it's super easy to make this minimal version. And last but not least, this is something we also really like to use, is we often use Flutter Web internally for stakeholders in our that we work with, just, for example, for debugging reasons, or if we have different branches with different versions of the application that we want to show, or just for API developers, for them to look up API requests that we do within our app easily in the network tab. This is usually very hard with the app, but this way they can check everything out themselves. So yeah, Flutter Web is kind of cool. And I just want to mention, because in this talk, we're going a little bit into detail of how Flutter actually renders, how it works. I set this up a little bit as an advanced topic. I'll just quickly repeat it, because probably all of you know that Flutter doesn't work like other frameworks by just, throwing out HTML like React does, or just using the components on the native system. But Flutter draws everything by itself, like a little Bob Ross over here. So the idea of Flutter is it has a canvas. It just says, give me a blank canvas. I will take care of everything because I'm a designer. And it just draws stuff. And this is very, very important to know for this talk. Yeah, Flutter is actually super responsive, because a lot of people often say it's not fast or it doesn't work well. But if you see this, it actually is really snappy. And that's the cool thing about Flutter. It's very important to keep in mind that Flutter is actually fast because of WebAssembly, because of the way it works. And once it's loaded, it's super fast. But that's actually the big if, because it's only fast after it initialized. And the thing that we usually have problems with, or that people refer to as slow, is this step, the initialization. So if I load the application, I have a white screen that will load and load. And of course, I overdid it here with the page speed. I made it extra slow. But it will take a while for the application to load, and the user doesn't know what's going on. And this is a problem. This is not something we want. But as soon as the bundle is downloaded, it's super fast again. I can click, and everything is super snappy. So the goal of this talk is not to talk about the second part, but about the first part and about ways how we can make this faster and about ways how we can solve this, or maybe solve this. So yeah, let's quickly, like for people who haven't worked with web yet, like talk about some typical performance metrics that are out there. I'm just not going to go into detail, but here you can see different rendering steps of the website that websites usually go through. Like we have the first render on the very left. We have the first paint, which is just, it shows a little bit. We have like the largest contentful paint when something above the fold loads. Then we have the cumulative shift. This is when basically everything has loaded, all the animations are finished, and the website stands still. And then in the end, we have the interaction to next point, IPN, which is INP, which is super important because it tells Google and other crawlers basically how responsive your application is. Because Google set out a goal to say, OK, we want applications to be as snappy as possible. We want the user experience for our users to be better. And that's why, and this is an important thing, the 3 on the right are actually considered core web vitals by Google and will be used in the ranking parameters. So if your website is fast, if it renders fast stuff, if it has less shifts, or basically it is very snappy, it will rank better. And this is something very important if we talk about web, right? So yeah, mostly Google talks with this, and the way they gather this data is by once a day sending a crawler over your website, doing this automatically. But, and this is also very important, they have Chrome under their fingers, and basically they use data that are in statistics of Chrome to actually evaluate this in real life. And all of this together will define these core web vitals. So yeah, performance matters. Like tests have shown that 30% of users leave pages that do not load within 6 seconds. So the page we had before, probably a lot of users would have dropped off. More users, of course, means more interactions. More interactions, of course, means higher chance of conversion, and therefore revenue. And it's very important, like I mentioned, Google uses page performance in ranking algorithms. So this is something we really have to be careful about. Let's quickly talk about, and as you see, I'm going over the basics very quickly and very fast. Let's talk about SEO and GEO. Most of you probably have heard SEO. GEO is a new term, basically generative engine optimization. It's AI bots and stuff like that, or crawlers that go on your website. You can nowadays optimize for them as well. And this is a big topic, more and more coming up. And so yeah, what do they like? Of course, they like core web vitals. They like page and bundle sizes to be small and better performance. And this is the most important of all, they like structured HTML output because it helps them to understand your content. And for every one of you who's been in the Flutter ecosystem for a while, for everyone who created a Flutter web version, you might think, this is not good because Flutter doesn't output any HTML. And that's a problem, but a problem for later. All right, so let's quickly see what structured HTML output is. This is a very minimal page. It has a title, it has some tags, it has some meta tags, some information about the website, just stuff the crawlers will see and categorize your page by. This is what we kind of want, but don't get. Very quick note on structure, why this is important. So as you can see here, like if I have some animals, I have wildcats and stuff like that, it is very important that this data is not just there, but the data is really structured in a way for machines to learn, because they would not know otherwise what lions are, like, or what wolves are. But if they get this structure, if they get these nested blocks, they actually know, oh, OK, that makes sense. Lions are part of wildcats and animals. OK? The opposite would be true if you see this. If you get a list like this, or if our crawler gets a list like this, they would have no idea what belongs to what, right? And it might seem strange that I'm going on this point, but you will see in a second why. Like, this is a very important part of this. So let's take a quick look at how our website currently works. A user visits our page. Nice. They get the index.html, which is in the web folder. And as most of you know, it's just a blank page that has a canvas tag inside and a script tag that loads the Flutter bundle. And this is exactly what happened in our screen. So we had a white page because there was a white canvas with nothing on it. And there's about a 7 megabyte bundle that takes a while to download. And until this bundle with the instructions is downloaded, there's nothing to show. There is nothing the browser knows what to show to the user, and that's why we have a white screen. And this is kind of the root of the problem. When this bundle is downloaded, everything is there, and all the instructions are there. The bundle will render the application on the client into the canvas, and everything will be beautiful and work fine. But up until this point, this is where we have the problem. And yeah, like I said, for crawlers, it's the same thing. Crawlers don't wait for this bundle in most cases. They just want what the HTML output gives them, and this is what they take for granted. There are crawlers like Google that actually renders JavaScript, but again, when? So our problem is this canvas tag in here, and that we don't have anything to show here. So no information for browser until the bundle is initialized. Search and Aircross don't get any information. They just know there is a canvas, but they have no idea what's on the canvas. And even if it's a fancy crawler like Google that actually renders JavaScript, even though with a smaller budget, the problem is it doesn't know what's on the canvas. Google doesn't do ACR on your website. And there's sometimes rumor that it does, but it's true for some of the images. They are actually analyzed by Google, but they do not do ACR on all of the hundreds of billion pages every single day they crawl. So if Flutter renders in this canvas, even if Google does the whole rendering process, it will still see an empty canvas tag and not know what to do with it. And like I said, this is what we need to take a look at. The problem is the foundation of the web for the last 30 years has been HTML. All the crawlers care about HTML, all the browsers care about HTML, and there's nothing else. And as cool as it is that Flutter found a different way that works really well cross-platform and is super fancy, the problem is pixels on a screen like we have it is not structured HTML. And so how do we solve this? There's basically two bigger categories that I want to separate this into. The first one is small optimizations that we'll take a look at to decrease the time that we actually have between these white screens and loading. And the second thing is server-side rendering, which is the holy grail, and we'll see if we get there. So yeah, let's start with the optimizations. I will go through them rather quickly. There's a couple of topics that I just want to mention for you to have heard them. I will not go into too much detail because usually it's easy to find them. And second of all, I've been working on a blog article about this, but yeah, didn't have time to finish it up. If you're interested, check out from time to time my X or LinkedIn. I will definitely post it in the next couple days. So yeah, let's start with the easy and fast ones. Improving loading time on an app level. That's the first one I want to start. There's some easy fixes for that. The first one is more psychological. Show a loading indicator or something. You can add a loading indicator in the index file, and as soon as the user gets to the website, a small JPEG, GIF, or whatever will be downloaded and show the user, hey, something's happening, they have to wait. Doesn't really change the loading time itself, but makes it easier for the user because they know actually something's going on. The second thing is tree shaking and avoiding unnecessary assets. So most of you probably use material icons or something like this, and there's a million material icons that would be in your code base. If you use this tree shake icons option, it will actually remove all the ones that you don't use and thereby reduce the bundle. There's a lot of other tricks, and with the release option, it does the same thing for unnecessary or unneeded code. There's JPEG, there's PNG that everyone uses. PNG is awesome because it has transparency and half transparency, super nice, and so everybody uses it, but they're kind of huge. There's modern file formats or image formats like WebP and AVIF that are a lot smaller without losing any of the quality, and they should be preferred because that makes the whole loading process even faster. And last but not least, while your bundle is downloading, and we have some time to wait, we could do other stuff. For example, if we know we're going to call an API on an external domain or we're going to download our fonts from another domain, we could already tell our browser in the meantime, hey, go ahead and download some or prepare the download of something already. Do all the handshaking protocols and stuff like that so that as soon as it's ready, it can download immediately. It's not that big of a thing, but it's still, you could do it very easily with one line. So yeah, let's talk a little bit more meta, basically not exactly in your application. One important thing that usually goes without saying is enabling compression. You know, there's a lot of different compression stuff like gzip, Broadly, Stopfly, and so on and so on. make sure they're enabled, because that makes a huge difference. Like, you could cut the bundle size from 8 megabyte to maybe 2 megabyte, which is, of course, a huge difference. And a small note, JavaScript, HTML, CSS is almost always enabled by default. But WASM, like the WebAssembly files, are rather new. So most servers don't think about them, but they're actually also quite big. So make sure to check that they are also optimized. The next one is set cache policies for hashed assets. So you have hashed assets that will always be unique. You can set the cache policy for a year, so that if somebody visits your website the second time, it will be super fast, because they will just have the 8 megabyte bundle already saved. And yeah, the last one on this list is actually a rather small one. Add a sitemap XML or robots text file. Tell robots what they're allowed to do on your site and what not, and tell them about your subpages that you actually have. This is kind of important, because we don't really have links usually in Flutter, or we don't have them visible for crawlers. So giving them a sitemap helps them to scan your site and go on different subpages. OK, let's go to the level still manageable. A little bit more effort, but still doable. These are mostly structural changes. For example, use URL and real strategy. This is actually super important. Like by default, Flutter will use this slash hashtag and then the route in Flutter Web. The problem is for crawlers, this is not a unique site address. This hashtag just means basically a location on a single page, and so it will not index it as a separate URL. So even if you give it 1 million hashtags, it will think this is one site. So you have to change it, and you can do this with this package, like Flutter Web Plugins, URL strategy. With one command, just enable it, and it will just use paths. Important about this is you have to prepare your server to do the rewrites. So otherwise, they will expect this about page to be a folder on your server, which doesn't exist and would give you a 404. But you could tell it, OK, whenever you get this path, always go back to the index file. Flutter routing will take over and render everything correctly. Yeah, my biggest tip, if there's one thing I can really recommend that's super easy and super important, is this one: enable semantics and use semantics widgets. There's 2 reasons for that. The semantics widgets are there for screen readers and to support people with accessibility. But at the same time, the good thing about it for us is adding something for screen readers means they have to add structured content data to the DOM. And they do this by basically overlaying the Flutter tree with an accessibility tree that is minimal and contains some of the content. So users with screen readers actually see something, because otherwise their screen readers would see the same thing as a crawler. And by doing that, you actually can have 2 benefits. First of all, you make your site more accessible. And second of all, crawlers can finally find at least some basic information on your website just by doing that. And it's super easy with one command in the run app method. And another one, this is often overlooked, is changing the meta title description OG data whenever you change screens. So if you're in a screen and you switch away, let's just say we have a list of news, and I click on a news item, and I go to a detail page, you can actually tell the HTML wrapper to change the title, which is visible in the browser tab, but will also be used by search engines for title, description, and so on. And since this is outside of the canvas, it's part of the HTML head, it will also be indexed by crawlers like Google Crawler once they render your website. So these are really, really small things you can do very easily, and they have a huge impact already for crawlers. They have a huge impact for your website as a total. Last level, or almost the last level, hard. Now we talk about providing HTML outputs. This is more something for crawlers. Like if you don't care about SEO, GEO, it's not such a big topic, to be honest. But if you care about crawlers, if you want to make your site ready for crawlers, you definitely have to provide some content. Like I said, Google will not be able to read what's in your canvas. So there's different approaches to do that. You could either, if you have a small site, maybe make a small couple, like an about HTML file where you add some content. Or if you have a lot of websites, you can do this dynamically with a like server-side script language or a tool or framework like Jasper or something, and just create the HTML content and provide it by the server. Same goes in this case, like this was for metadata. Same goes maybe for an HTML version. Like there is the option to provide an HTML version with the correct ARIA labels. to tell crawlers, yeah, you cannot read this page because it's just a canvas, but there is, at the bottom of the screen, there is an HTML link that's readable for you. And with this, you can basically deliver a second version that doesn't have to be styled, that doesn't have to look good. It just should have the content that we actually need. And third but not least, basically add some schema org structured data. So schema org is basically a convention about structured data in websites. It's not visible to users. It's just, you can add these as JSON blocks in script tags on your site. And it's basically how Google, for example, scans for products for Google's product search. So if you want to get your products into Google News, if you want to get your stuff, other way around, if you want to get your products into Google Products or your news articles into Google News, this is what you would use, basically. You give these tags. They're not visible for users, but they will be there and help you to see everything. All right, now we got the easy part. What about, I promised a little more. I promised like we tried to solve this. So let's go to the maybe impossible part. Server-side rendering. This is a concept that exists in the React ecosystem or in the JavaScript ecosystem already, like some call it universal rendering, server-side rendering, hydration, stuff like that. And I've worked with it a lot in React, in Angular, in Vue, and everywhere. And I just wanted to have the same thing in Flutter because it's super cool. And so what I set myself out to do is to find out basically how would server-side rendering work in Flutter. So what is server-side rendering? If we look at our page, this is the problem we had. We have a white page, and at the same time, as I mentioned, we have this problem or this issue with a canvas that just doesn't say anything. This is the problem. This is our workflow that we already saw. We get an empty page. There's nothing the browser can do to actually get information without us telling it. So what's the solution? Like, where do we hook into this to solve this problem? And where server-side rendering comes in is, the idea is, before the browser even gets this index HTML that contains the instructions, or the instructions to download instructions, we want to hook in and send basically a first version of the website that the browser can render immediately until our bundle is downloaded. We will see this in a second in our flow. So the user visits our page, and instead of just sending a blank HTML, a static HTML, we will try to generate HTML code from our Flutter application, hopefully, and get this into a file or into a request, and send this over instead of the blank file. As you can see here, we have some button here and stuff like that. And then as soon as the browser receives this, it can render the HTML directly, while simultaneously downloading the Flutter bundle. And even if it takes 10 seconds, doesn't matter. Once it has the Flutter bundle, it will render our canvas, overlay it over the HTML that it rendered, and hopefully everything will look the same. Hopefully. That's the basic concept that we're trying to go for. So yeah, and we could maybe cache this, which would be even better, because then we don't calculate so much on the server. And yeah, I thought this would be a weekend project, of course. I talked smart, I locked myself into a room and I just started to go on. It wasn't like 2.5 months, I think, but not all the time, but I spent a lot of time on it, but it was super fun. Yeah, let's jump into it. I had a lot of approaches, so this is actually what I wanted to talk to you about. I didn't use all the numbers, I have to be honest about this one, but it seemed cooler like this. My first approach was, as some of you might remember, there's an HTML renderer. Super cool. Like, Flutter already has a renderer. They deprecated it, but I mean, if this would work, I would beg them to bring it back, and I would just use that. So my approach was this. I will take the web renderer, I'll run it on the server, then I will run a headless browser on the server just to get the output. I would save this in a file, cache this, and then send it over to replace the client. Everything will be good and super nice, and everyone will be happy. This is what it looks like. On the left side, we have the output. Looks amazing, right? Like, this is the Flutter Web renderer. Doesn't always look that good, but in this simple case, it did. And here we got some content, and as you can see here, that's amazing. We actually got words in there, what we want. So we have a nice design, and we have content. So basically, we have everything done. It works. Show over, I thought. And yeah, but then not really, because the closer I looked, after I was happy, I realized, you see the structure over there. Do you remember the animals that I told you about, that just go down like without any structure? The Flutter Web renderer cheats. Like you would think it builds your website and it positions stuff exactly on the position it should be. The only problem is they do this by positioning everything absolutely on the screen, but everything is just one list of diffs. And so as cool as it looked and as happy as I was with it, it's not a solution because that doesn't help me anything with crawlers, that doesn't help me anything with structured data. So yeah, I wanted to find out why that is, and I just wanted to remark on it very quickly. We'll not go into detail, but it's super interesting because we all know the trees like that Flutter has. And the interesting part, the reason for that is because the rendering of the Flutter renderer happens after the element and the widget tree. The element and the widget tree actually still know something about structure, about the properties. The rendering tree has no idea about properties. It has no idea about like the structure of your application or the widget structure. It just knows basically what to point where, like what to draw somewhere. And this is the problem, because in the beginning I was like, okay, then I'll just throw my properties in there and I'll add this and try to create a structure. But the problem is, at that point, it's too late for that. And this is how my 2.5 months started, by trying to get into every little tree and trying to get a way where I have properties and I have like widgets instructions at the same time. Yeah, so I had to go back to the drawing board, of course. Approach number 2. So I thought, the semantics tree, it worked quite well, right? Like I told you, the semantics tree has content, it has stuff I can show, it shows stuff, so that should work, right? So yeah, it could work because we provide structured output. We need that for screen readers. It contains text content, and it's a core Flutter feature, so I even wouldn't have to fidget around with it, which is nice. And this is what the structure looks like. Amazing. I mean, it's not perfect. There's some concatenated strings, but I think with some semantic widgets, I could get this working better. Exactly what I want. The only problem is, that's what the content looks like. Because if you think about it, a screen reader doesn't really need a design. It doesn't really need like colors and stuff like that. And again, if I hook into the screen, like the semantic tree, I'm too late, or I'm too early. I will not have any information about the structure, and I will not get any properties either. So yeah, there's some shortcomings that just didn't work out for me. There must be another way, I thought. Like, okay, so we tried these two. Both of them had a good solution. I tried to merge them, didn't work. Trust me, I tried. But I was like, okay, what I really want actually is I want to get access to the widget tree with the properties. So that's the only thing I want. What I would want is I have a simple widget here with a card. Like you see just the structured data, there's some properties in there. And ideally, I would want to get this in a simplified version, like just like this in a map that I could loop through and then translate, right? This could look something like this, that I say, okay, there's a card, the card I translate into a style, there's a color, there's a padding, or in this case, it should be a margin. But there would be something I could just loop through and I just create the tree. That would be so cool. And so I set out on a quest with a couple of tries to get this structure somehow in between. And so, yeah, I have a few honorable mentions. So first of all, I tried to hijack the build method and thought, okay, I'll just go in there and I'll just render out HTML instead of the widget. Problem is, I can't change the return type. So I thought, like, I'm smart. I can do this. I will just copy, like automatically, the whole build folder and just swap out, just to test. I will just swap out little parts of the rendering method and try to find out like how I can hook there. The problem is, even with my very, very small code base, it was super messy and didn't work at all. So I thought, okay, this will not work. Okay, new approach. I tried to add a hook somewhere in the constructor of the widgets. Basically, ideally somewhere, stateless widget level, something like this, where I catch the properties, I record in a state upwards where I got my, or how this hangs together with the other widgets, and try to build this tree out of it. But the problem is the factory is called too early, so this didn't work. Okay, then I was like, I tried to add a manual call to a store, find that record of this widget and the properties, and combine them and calculate the position where it should actually be in the tree, and try to work with this. Problem is, it didn't work with low-level widgets because I can't change the container and I can't change like inkwell and stuff like that. And then in the end, I was like, okay, I have it. I will create a new Flutter target. Like there's a web, there's iOS, Android. It can't be that hard. I'll just check out the Flutter code base, and I already started forking like the cut of Flutter code base, and I was like, ooh, that didn't go so well last time. I might not try this again. So yeah, I stopped it with that. Let's go to another approach. You know how these projects go. It was 4 in the morning, and that's when it struck me, like, this genius idea, this epiphany. And I was like, okay, AI will fix it. So, okay, no, hear me out. Okay, that was my approach. Okay, I'm going to take a screenshot of the page on the server. Easy, right? Then I will convert the screenshot into perfect HTML and CSS because AI, we know. And of course, this will cost something, but it was late and money means nothing to me right now. So I was like, okay, maybe I can even cache it and save some of the money that doesn't mean anything to me. And this is the flow chart I have here. So basically, this is the thing. I want this, and there's AI magic. And I suddenly realized, like, when I was almost done with it, I was like, yeah, shit, what if something's not on the screen that I took? Because, yeah, but no problem, because, I will just render everything that I can find, and then this is not a problem. But then I thought, like, okay, the problem is on the image, you don't know where this links to, right? So I found another solution, which is basically, I will just make 2 different screens. One screen that annotates the colors in one color that's not on the screen, and I have a clean screen, and then I combine them, and I read this out, I pop this over, I delete the other screen, and then I just show it, and everything will probably work quite well, but then I found another solution, I just went to bed. So, yeah. Let's go to the next approach. Next morning, I was like, okay, the semantic tree actually worked. You remember? Like, it actually worked. I got the content. But if only I could make the visual rendering look better, because that was my problem, right? So what if we fake the visual rendering? So what if we don't show the rendering, but we just fake it? And so my idea was like, what if I just take a screenshot and I show a screenshot of the application until the bundle loads, and then I just replace it, like just server-side rendering, basically, on a pixel level. Awesome, right? And as you can see here, look at this. I will hit Enter now. Immediate result. Did you see that? Thank you. Yeah, there is a little bit of a change. There's a little bit of a problem, but it still works, right? I was super happy. I was really, really happy. I sat down, I drank my tea, and I was like, yeah, nice. But then I made my browser a little bit wider, and suddenly it didn't work because the screenshot was made for a different resolution. Still wouldn't be a problem, but to be honest, like, maybe we need to make 100 different screens for every single size or so. And of course, the content is strongly cached. So yeah, like, it would be actually quite good because it improved the perceived performance for users. It improved FCP. It didn't change the layout so much. It's improved the crawlable content. Unfortunately, it still took 8 seconds until you could click anything. So we couldn't do anything about that. And the layout shifts sometimes where the different resolutions didn't work. Yeah. I went to the next one. I said, like, next up, I'm trying to add a hook method in the Flutter core itself. But to be honest, I didn't get to that. Now we're here. I liked my last solution, but it was awesome. So I thought, like, OK, good enough. That's a problem for another week. And yeah, with that, I'm coming to a conclusion. So basically, what would I recommend based on all this craziness? I would not recommend spending 2.5 months on this, to be honest. But if you work on a site, definitely try to statically render HTML out and just provide it to the website. Like I said, do it dynamically for bigger pages, do it statically for smaller pages, create an about site that just contains the content. Definitely use all the optimizations I told you about. They really, really help and are super easy to implement. Provide metadata, definitely do that. If you go the route of you can't do it right on the server, use semantic rendering. That always helps. And if anyone's crazy enough and tries the semantic plus screenshot method, I would really, really, really love to hear from you. Like, just how it worked out or how it broke your server because it had 1 million pictures. Last question, because this gets often, or I get asked this a lot. When would I use Flutter Web? When would I avoid it? Whenever SEO and GEO are not important, nowadays, to be honest, I would use Flutter because I always have the option to create an app or a desktop application for it. This is often the case with stuff that's logged in because you don't want to, you don't want to crawl that anyway. And even if users have to wait 4 minutes, if they have a login, they don't care. So I would make a marketing site that's really fast, not with Flutter, and then link to portal or login, and that goes to a Flutter page. When you use the expector, it doesn't care about loading time, like in an intranets and stuff like that. I would never use it or not recommend to use it like if the content really needs to be crawlable or SEO is a big factor. And I would also not use it for marketing pages at the moment. So yeah, did I solve server-side rendering for Flutter? Not really, but I had a lot of fun. And I hope somebody smarter than me gets inspired by this and solves it very soon. So with that being said, thank you very, very much. Thank you.